Great, thank you. And so we have a quick agenda overview. So I just sort of went over, but I'm excited today for a deep dive into La Nina and what that may mean or what that could mean in different ways for this upcoming water year. And we'll go into our regular updates and have time for discussion. So again, our Washington Water Supply Availability Committee provides an important consultative role to the Department of Ecology in terms of our drought declaration process and current and forecasted water supply conditions, and in particular with our drought declaration process as we're upcoming to one about our hydrologic threshold. And I'll do a recap on that in just a moment. And for our meeting here today, again, we're going to share and assess information on water supply conditions as we enter and get a little more into water year 2025. And as a quick recap, as I think most folks here know, that back in April of this year, Ecology declared an essentially statewide drought due to low snowpack and a warm and dry forecast, with limited exceptions for the areas served by the utilities of Everett, Seattle, and Tacoma, as they had healthy storage from managing for drought conditions earlier on in the year. And again, when we talk about drought here in Washington, we're really particularly talking about the impacts for water supply. And that's where those snowpack conditions from this year were so important. So drought in Washington law means two things. First, a hydrologic threshold that an area is receiving or is projected to receive less than 75% of normal water supply. And by normal, that's capital N, referring to the average of the last 30 years from 1991 to 2020, as well as a hardship threshold that water users in the environment are or expected to experience undue hardship from those drought conditions. And back in April of this year, we met those conditions from a range of different water supply factors. There's not one way we look at that water supply threshold questions. That includes snowpack, precipitation, temperature, soil moisture, the water year to date numbers, as well as forecasts. And in terms of those impacts that we saw some of those expected impacts around fallowed land, but full economic impacts for agriculture are still to be determined. And we know particularly for the Yakima Basin, there are concerns going into this water year for next summer with storage being so low. There were also impacts for fish and in-stream flows, but as Karen has said in earlier meetings, there were points in which those impacts could have been a lot worse. We got a little bit of rain in August, but still definitely impacts, particularly in Dungeness and the central part of the state. And with public water systems, we saw some impacts, but we also know that work towards resilience that some of those smaller water systems have done in the past did help to lessen some of those impacts. And with the drought declaration in Washington, again, that does mean that two main things for ecology and for the state that we here at Water Resources can expedite the processing of water transfer applications, but all the other requirements, including mitigation, are always still in place. And that second, we can open up drought response funding, specifically to help mitigate the hardships that different public entities are facing from drought conditions. And that is specifically for emergency needs and responding to current drought needs from these conditions. And I say that as compared to preparedness or planning for future droughts. And again, these are the list of public entities that are eligible for drought response grants under a drought declaration. And as well, ecology can use drought response funds for interagency agreements for ways that other state agencies may be uniquely positioned to respond to droughts, as well as opens up eligibility for federal funding for public entities across the state. And again, these drought response grants are still open, though I will note that for any applications that come in at these times, they still need to be for projects that are responding to impacts caused by current drought conditions, where if you folks are seeing water supply impacts from these drought in 2024 impacts. And again, a couple of examples can include leasing water. We've seen that happen this year, as well as the transportation of emergency water supplies. We saw that happen in 23. Or eliminating migration barriers to fish, like when folks build recreational dams in the summer, Although for grants, any else to come in, we are sort of past that point for fish. And just noting again that the emergency rule that supports keeping those grants open was reissued on August 14th and may be reissued again in December, as just with the State's Administrative Procedures Act, emergency rules are for 120 days at a time. And while our drought declaration is still in place until April of 2025, and we are keeping the grants open for any needs that come up responding to conditions that have resulted from these 24 drought year impacts. And as we, again, particularly in Yakima, we see concerns where storage is so low as we're going into and are now in the beginning of water year 25. And ecology will continue to evaluate these conditions throughout fall and winter, but we'll be looking for evidence of drought recovery, particularly in the snowpack, before considering rescinding that drought declaration any earlier than where it's currently slated to go through April of 25. And now I will pass it over to Karen at the Office of the Washington State Climatologist. Lori, if you could tee up that screen share, that would be great.
Thanks so much, Caroline. Good morning, everyone. And I appreciate the extra time this morning to talk a little bit more about La Nina. I wanted to mention that Dr. Nick Bond, the Washington Emeritus State Climatologist, is on the line to help answer questions too. So happy to have his expertise in the room as well. So I'm going to go ahead and get started. If you can go to the next slide, please, Lori. So water year 2025, we're about 6 weeks in. So this is looking back to October 1st, temperatures on the left-hand side, precipitation on the right. Overall, we've been a bit on the warmer side. Some areas of near normal temperatures, which are sort of those like grayish white colors on the map there. But if you average across the state, we're about 1.3 degrees Fahrenheit above normal. That was for October. So October alone tied as the 29th warmest in the 130-year record. Precipitation, some more variability. The map is showing the last 6 weeks. The stat below is showing just the October precipitation, which was about 84% of normal across the state. So not really record-breaking, just kind of in the middle of the pack, down at the 58th driest for October. But looking at even just the past 2 weeks where we've seen some precipitation on the west side, really still drier than normal on the east slopes of the Cascades there, kind of southeastern Washington, but then some other areas with normal to above normal precipitation so far. Next slide, please. So this is what the U.S. Drought Monitor is looking like as of this morning. It was just released. Western Washington, there's been some improvement. So the right-hand map there, those green colors are showing that there was a 1 category improvement over the last 5 weeks. So since we met about when we met last. So responding to some of that early fall precipitation that we're seeing, and then the improvement in Eastern Washington, that little green strip there was just made this past week, removing some of that severe drought there because the indicators didn't really seem to support severe drought at this point. It's still remaining in moderate drought, as is most of the rest of Eastern Washington at this point. Go ahead to the next slide, please. I wanted to just put in a plug, yeah, there we go. For the water year impacts assessment is a report that I've been leading for the past 4 years. It reports on the water year conditions around the Pacific Northwest of the water year, and then also links it to sector-specific impacts. So I'm gearing up to get started on the 2024 water year impacts assessment. Right now, there's a survey that's still available where you all are a great audience to fill that out if you haven't already, to discuss any specific impacts that you saw in your area related to either abnormally dry conditions or even abnormally wet conditions. So that survey, I can put the link in the chat when I'm done speaking, but it's open through November 27th, so almost 2 more weeks where that's available to fill out, and I really appreciate your input. All right, next slide. I'm going to jump into La Nina now. So our current status is we're still seeing neutral conditions in the tropical Pacific Ocean. On the left-hand side there, that is the official probabilities of whether we'll see a La Nina, a neutral, remaining in neutral conditions, or an El Nino for the different 3-month periods of this upcoming winter and spring. And actually, the chances of La Nina have dipped a little bit since our last meeting again. So the probabilities have dropped a little bit, still looking like about a 75% chance that La Nina will develop sometime in the November, December, January period. But the chances of remaining in neutral have inched up a little bit, about 1 in 4 chance that our one will remain in neutral conditions. We're feeling a lot more confident that if we do reach La Nina, it will be a weak event. So on the right-hand side here, those are the different model predictions. The one that is showing a moderate to strong La Nina is pretty much out to lunch. The rest of them are all agreeing on a weak La Nina event. And so I think there's always a little bit of confusion about what a weak event means. So typically it means that there's less consistent impact across North America in terms of like what the typical La Nina pattern is that we see. And I'll get into that in the next few slides. But what it doesn't tell us is anything about the strength of the temperature or precipitation anomalies in a given region across the US. So, for example, the Pacific Northwest has seen very cold anomalies even in a weak La Nina event. Now, we can't say for sure it was the weak La Nina that caused those anomalies, but there really isn't a correspondence between the strength of the La Nina or El Nino in the tropical Pacific and what we see over land. Go ahead to the next slide, please. So just a refresher for those of you that hear La Nina and El Nino all the time and haven't thought about what it really means in our physical system in a while. So what this is showing is a schematic. The sort of reddish brown color is the coastline across the Americas. So like North America going to Central and South America on the right hand side of that plot. And then so we're looking at the kind of a cross section of the ocean, and then also the surface of the ocean is what those colors are. So for La Nina, we tend to have stronger easterly trade winds at the equatorial Pacific. So those winds are stronger there. And what happens is you then have cold water that upwells from below along the coast of South America. So you can sort of see it in the schematic there. It's hard to not have a pointer, but there's colder upwelling water off the coast of South America. And then it also shifts sort of this area of thunderstorms, convection, rainfall further west. And so that shift in that the atmospheric part of the phenomenon is what controls something called the Walker circulation. So that's that little arrows in the atmosphere showing how the air typically moves in correspondence to what's happening in the ocean. And so the Walker circulation is then what has its like fingerprints along the weather patterns for all across the globe. So I'll just talk through the El Nino real quick. So it's pretty much the opposite. Instead, the easterly trade winds relax a little bit. And so that sort of warm water that's typically piled up in the Western Pacific sloshes across the Pacific basin. You get a larger warm pool. And with that, that area of convection and thunderstorms moves with it, and you get reduced upwelling, so warmer water off the coast of South America. And then it also impacts the Walker circulation and impacts our weather pattern. Next slide, please. So more than you ever wanted to know about. And so this is what we tend to see across the United States during a typical La Nina. So what happens is we have this high pressure off the in the Pacific Ocean, which pushes the jet stream sort of up and over that high pressure. So we have more of a northern or northwesterly flow over us in the Pacific Northwest where that jet stream is. So rather than getting a lot of our storms coming up from the south or southwest, which tend to be warmer, we get this cooler air. So we tend to see colder temperatures and a little bit wetter conditions during La Nina. Next slide, please. So one of the most common ways that we define La Nina and El Nino is through this oceanic Nino index, which is shown on the left-hand side, which it's a 3-month running mean of sea surface temperatures in an area called the Nino 3.4 region of the equatorial Pacific. So it's sort of in the eastern equatorial Pacific where we measure that. And so on the left-hand side there, that's showing just the really long time series of how we switched from La Ninas to El Nino episodes, going back to 1950. And you can see here on the very current part, we're just starting to dip below that 0 line. Anything below the dotted blue line is classified as La Nina according to this measure. And I would say that this measure is not that hard to get to. It's like a lower threshold of classifying an El Nino or a La Nina. So looking at our current weekly sea surface temperature anomalies in the tropical Pacific there, you can see some blue colors representing below normal temperatures where we would expect to see them start to develop during a La Nina. Next slide, please. So I also, oh, that one came out weird. The title just says Southern Oscillation Index. So it's SOI is a different way we can measure El Nino and La Ninas. And so what this does is it compares the difference from average in air pressure from the Western Pacific measured in Darwin, Australia, to the difference from average pressure in the Central Pacific measured at Tahiti. So the anomalies here indicate the strength of the Walker circulation. It's more of an atmospheric definition of El Nino or La Nina. So here, these red colors mean that there's higher pressure than usual, and the gray colors mean there's lower pressure than usual. Air tends to move from high to low, so you would get the positive pattern is indicative of a La Nina, and then the negative is indicative of El Nino. Next slide, please. So not that important to keep in mind, but I'm only described it because these scatter plots that I'm showing next are using the Southern Oscillation Index definition of El Nino and La Nina here. So that is what is shown on the x-axis here. Anything colored red is El Nino. Green is classified as neutral, and blue is classified as La Nina. Every single one of these dots is the January to March average temperature over Washington state. So what I'm trying to get at here is what's the relationship between our January to March temperature and El Nino and La Nina. I should also note that this data set is using years going back to 1934. So you can see overall there is a relationship. Temperatures do tend to be a little bit cooler. You can see those blue dots are a little bit lower than what we see during El Ninos, the red dots, but there's a lot of variability. There's on top of that, what jumps out to me is those 3 neutral years, those green dots that are pretty cold temperatures, even though it was neutral. So those are a little bit of an exception to what you would tend to see in this sort of sloping downward graph. Okay, next slide, please. So this is looking at something similar. This is from the Western Regional Climate Center. So it's actually looking at October to March total precipitation. Same thing. Red is El Nino, green is neutral, and blue is La Nina. And here again, you can see some La Nina years. La Nina overall tends to be a little wetter than usual for Washington state. The circle on the right-hand side there, those squares are indicating the average. So the blue square is the average for La Ninas. The black square is the average for all years. And then the green is neutral and the red is El Nino. And so here you can see there's really a better relationship. There's a further difference between La Nina and all the other the data set as a whole or neutral or El Nino. So a little bit more confidence that there's more precipitation during La Nina years in Washington. Next slide, please. This one I wanted to show, it's looking sort of at the same thing, a little bit of a different way. So again, each one of these dots is a Washington winter. This time winter is defined as December through February, going back to 1951. And then it's color coded by La Nina blue, El Nino red, and neutral green. What's highlighted here is I circled some of our major drought years for Washington. And then also the red years were very strong El Nino events. And what jumps out to me here is they're all almost all above this gray normal line. So all mostly El Ninos are warmer than normal in Washington winters. You can see the same if you look at the blue diamonds. They do tend to be on the cooler side, also tend to be on the warmer side, or I'm sorry, on the wetter side. We don't see any blue diamonds in the warm and dry quadrant on this plot here. Go ahead to the next slide, please. This is the point I wanted to make here. These are box and whisker plots, again, showing the seasonal temperature averages for El Nino neutral versus La Nina. This is for the number 75 climate division. So the map there is showing it's sort of the west slopes of the Cascades and parts of Western Washington. And here, the temperatures are cooler on average during La Nina, especially in January through March and April through June. So there's a bigger difference in those box and whisker plots on the top compared to the bottom, where there's much less of any sort of signal for summer and fall for La Ninas. Next slide, please. And then this is the same thing for the same number 75 climate division, but looking at total precipitation for the different 3-month seasons. And here, really the above normal precipitation signal is strongest during October through December. So on that bottom right quadrant is where you can see more of a separation between the mean, the red line during the La Nina box and whisker plot compared to El Nino or neutral. Next slide, please. Okay, so one other look at sort of averages. This is looking at winter snowfall, not snowpack, at Snoqualmie Pass, going back to about 1950 through 2023. Again, color-coded by El Nino and La Nina. Again, we see more of the higher snow years tend to be during La Nina. Okay, next slide. So this was perfect timing because the ENSO blog just released some great maps about snowfall during all La Nina winters. So I'm going to walk you through them now. And what we're seeing here is these are the average snowfall during the 22 La Nina events in January through March. This is using the SST, the sea surface temperature definition, just for your own, just so you know. And what is cool about these plots is they actually detrended them before making the average. So it's not, they took out the fact that our snowfall has been decreasing in recent years due to climate change, and instead are showing that on average, the Pacific Northwest there's lots of dark blue. We get more snowfall during La Nina years compared to the normal January to March 1991 to 2020 period. Next slide, please. So I like that they did this map as well, because sometimes when you average over multiple years, you can have just a couple really big snow years that are making the overall average look snowier than what we would experience. So what they are showing here is the count of those with below average snowfall. So they took all 22, and in the Pacific Northwest, the signal is particularly robust compared to some of the other regions of the US, because out of the 22 La Nina events, less than 7 of those winters had below average snowfall. So a majority of them, it's not just a few big snow years that are really carrying the day on La Nina. A majority of them had above average snowfall. Next slide, please. And I am keeping an eye on time, so I'm still doing okay there. So then what they did out is they separated out some of the weak La Nina events because we're expecting this current one to be weak. There's only 9. But what we're seeing here is that Washington is still showing above normal snowpack or snowfall, I'm sorry, during the weak La Nina events. You can still see in the Cascades and the Olympics, that sort of dark blue there. The signal, if you were to compare back to that previous map, does change quite a bit for some of the other parts of the Pacific Northwest. Like it's really not strong in Oregon. And it's less strong for parts of Idaho as well. All right, next slide, please. So the menu bar on the top should say early indications that this La Nina may not be the main driver of our winter weather. So to add on to all this, there's some research done by a colleague here at the University of Washington, Andy Chiotti, who has shown that La Nina events with a strong atmospheric signal are really the ones that impact our weather the most. So there's been a lot of work done on this. And what Andy has found is that the number of clear sky days, which represents less thunderstorms and convection in the west central tropical Pacific, are critical in determining the impact on North American weather. So this is the count of those days going back to 1979. The blue bars are the 6 La Nina years that have impacted our weather in the US the most. And by early November, those years already had a higher number of clear sky days. So 2024 is shown there. It's the last bar on the right-hand side and doesn't have nearly as many days, meaning that the atmosphere isn't responding to the ocean or reinforcing the pattern as we would hope it would be doing by this time. To end up being a La Nina that really impacts our weather in the US. Some caveats here are that the 1998-1999 snowpack year is one of the 6 that's shown. That was a huge snowpack year for us in Washington. There's only 1 weak La Nina included, but it is included. So just further evidence that weak La Ninas can still impact our weather. And of course, we can still get a big snowpack year even without having this index qualify. Next slide, please. So shifting to the Climate Prediction Center's outlook for November to January, which of course they take into account the possible development of a weak La Nina. They're showing about equal chances for temperature, so really not betting on the cold La Nina signal yet for November, December, January. And then precipitation, they're putting out higher chances of above normal precipitation for all of Washington for the early part of the fall and winter. Next slide, please. And the January to March outlook there's been a little more consensus coming together since our last meeting regarding the below normal temperatures. So the Climate Prediction Center forecast has been saying for a while that we're expecting our temperatures to be below normal from January to March. But some of the seasonal forecast models really weren't getting on board. I'll show you in a couple slides that they are doing a little bit better there. And then the Climate Prediction Center is still calling for above normal January to March precipitation. Next slide, please. So this is what I was talking about, the temperatures. So this is looking at January to March. This top plot is the average of all the models below, except for the one on the bottom right, the IMME. So this is the National Multi-Model Ensemble agreeing with the Climate Prediction Center that January to March has higher odds of being below normal temperatures. And then the individual model thumbnails are shown below. A lot are saying over Washington have blue. My one cause for hesitation on being super confident about this forecast is the International Multi-Model Ensemble, which is that bottom lower right. Thumbnail does not have cooler temperatures across Washington. They have it up in Alaska, parts of Canada, but not in the lower 48. Next slide, please. Precipitation, still going strong with the idea of above normal January to March precipitation. We can see that in the model average on the top and then in most of the little model thumbnails below. Next slide, please. Okay, so to summarize, only spent a little bit of time on water year 25 since it's so new, but it has been warmer than normal statewide so far. For precipitation, it's been more varied, wetter than normal in the northern Puget Sound region. Bellingham in particular has been getting hit by a lot of our recent storms, and then parts of northeastern Washington, drier than normal in the central parts of Washington, the east slopes of the Cascades and southeastern Washington. Weak La Nina is still more likely to develop than not, but it is lagging a little bit behind what we expected, and also the likelihood that it might stay neutral is slightly higher than at our previous meeting. Overall, there are higher chances of above normal fall and winter precipitation, so those forecasts feeling really confident about. More consistency in the forecast of below normal winter temperatures, but still some uncertainty. So like I said, the international multi-model ensemble is what's causing me to hesitate there. So I think we might have time for questions. And like I said, Nick's on the line too. So Nick, feel free to pipe in.
Thank you, Karen. That was great. Yeah, I do want to give some time for questions about right now, but about everything you just presented. So I'll give a moment for folks to think of any questions, and I will have one or two questions as well. Yeah, thank you, Karen. This was great.
Hi, Karen.
Yeah.
I've got a question. Yeah, that was awesome. Thanks. I'm sorry if I missed it, but I'm curious what you might see in like the long-term trend of La Nina and ENSO in general, as far as kind of regular spacing or the duration. Do we see any kind of changes in that, or the magnitude of it, and kind of the longest term trends that you can look at?
I don't think we're seeing a lot in terms of how it's changed in the observations. There was recently a triple La Nina, which was a bit unusual, but not unprecedented. So 3 La Ninas, 3 winters in a row. I think the next question my mind goes to is how will this change in the future with climate change? And it's really uncertain right now. There's some mechanisms that would point to us perhaps having more years of El Nino, and then some other mechanisms that point to more years with La Nina. Nick, did I miss anything? Other Nick Bond.
Yeah, it's a matter of quite a bit of interest to the climate community. And I would say actually in the last couple of decades, we've had a disproportionate number of La Ninas in the observations. Now, that's a short time to, kind of assign any sort of reliable trends to. But there is some folks that are saying that could be a part of the system. And certainly the way, if we do have a La Nina this winter, it'll be 6 out of the last 9 that have had them, and that's unusual, and that has helped bail us out. And conceivably, that would also kind of help alleviate the warming that is occurring globally. And so, great question. We don't really know the answer there, but some of the recent years have been, yeah, there have been a lot of La Ninas, and so that's intriguing.
Great, thanks.
Yeah. Thank you, Nick and Nick, for that question and that support there. Other questions from folks? I'm looking for physical and virtual raised hands. While folks are,
I had one.
Yeah, go ahead.
This is Brent. So on that chart where you showed the most impactful La Ninas with the bar charts, I was just wondering what was used to define which was the most impactful to Washington or to the Western states on that. How is that decided? I guess.
Yeah, good question. So that's coming out of the Coyote and Harrison paper back in 2015. I think what they did, and Nick, you can bail me out if I'm wrong, it was the whole US, so it wasn't specific to Washington, and they were looking at um, how well the anomalies matched the typical La Nina pattern. So it wasn't just one specific spot, it was over the whole US.
Yeah, that's correct. And both considered, circulation anomalies and precipitation patterns and so forth. So, um, yeah, and so it wasn't geared just for us. And
Okay. But it
just
was looking at like precip and temperature anomalies that actually happened across the
yeah,
US. Okay.
yeah, and just since we're still on the subject, one thing I wanted to mention was kind of parallels to this winter we're going into here. In recent years, our 2006 and 2017, in which we had relatively robust El Ninos going into weak La Ninas, and both of those were kind of more run of the mill in terms of our snowpack. I don't know, have the exact data right there, but there's if you have 2 years, recent years of precedent, hard to generalize from that. 2006 and 2017 would be the ones that match the present one. And then one last thing I'd like to mention is in support of what Karen was saying, the waters off our coast have cooled a bit in the last month or so relative to normal. They were warmer than normal right at the end of summer. And so that will help keep our boundary layer, atmospheric boundary layer, for being that much warmer than it otherwise would be. And so that should help in terms of keeping temperatures down a bit.
Great. Thank you, Nick. And Karen, do you see Chris's question in the chat about resources, about our annual list of ENSO types?
Yep, I can respond in the chat.
Okay, great. Thank you. Actually, I have one more question for you, Karen and Nick Bond, is this question about the past years that did have La Ninas that had an impact for our snowpack and precipitation temperature pieces. Were you all able to see in the data if those were years where like the transition happened sooner in like December, November, or were there years we had those like snowpack impacts and didn't have the transition until like January?
When you say transition, are you talking about to La Nina or in snow?
To La Nina. Like if the transition to La Nina came like later in winter, did that like were there years which we still had impacts to snowpack, or did that have an impact not meaning as much for snowpack?
Yeah, I'd have to look closer to know to answer that specific question for sure. Of the 6 ones that Andy identified as being the ones that have the impacts across North America, those would have already the La Nina would have been more developed at this point in the season already. But with that said, I don't know for sure about like the onset of La Nina and Washington snow specifically.
Sure, but that's still really interesting that for those 6, the onset, at least for North America wide, would have already happened by now.
Yeah.
Yeah, great. Thank you. Yeah, thank you again, Karen and Nick Bond, for that deeper dive there. Super helpful and interesting. With that, I'm going to pass it over to Nick with USGS. And great to see you, Nick Bond.
All right, I'll share my screen here. It says it's been disabled. Would you be able to
1 second.
allow me? Okay.
Great. You should be good now. Thank you.
Sure. Thank you. Here we go. All right. Can you see it all right?
Yes, thank you.
Great. Yeah, thank you. So yeah, I'm just going to talk about stream flow and groundwater conditions in the state. I may have showed this photo before. It's actually from last winter when we were measuring stream flow, some stream gaugers down here, downstream of the bridge, measuring at Bolt Creek. while we were sampling for suspended sediment and other constituents coming off the Bolt Creek fire. So it's always still on my mind. We're always watching during these events to see what samples we can get there. So starting with the 7-day average stream flow in the state, as you can see, a lot of green dots here indicating normal stream flow conditions at many of our gauges. I'd say most of them, which we'll see in another slide, as well as some below normal and even some much below normal conditions spread out to the eastern part of the state, and here just in the central part, just west of the Cascades. And then zooming in here, we'll look at these 8 index gauges. We look at every time we meet that have near natural stream flow conditions. Just pulling this data from that map before, we see kind of a reflection of that overall trend, where the western part of the state having normal stream flow conditions compared to the eastern. 3 of these gauges have below normal stream flow. Excuse me. And looking at again at that 7-day average, kind of the area weighted across basins here, you can see that a similar trend of largely normal stream flow conditions, with the exception of to the east and the southern part of the state, still having record low values here in the Columbia and Roosevelt basins. So continuing with the 7-day average stream flow, but now looking back to the last 45 days, this plot we normally look at, which shows the percentage of USGS stream gauges on the vertical axis. We usually look at this 50% just as an indicator of what, half or most of our stream gauges are sitting at, and that also shows that we're in normal conditions, or at least half of our stream gauges are flowing at normal conditions, looking down even to 80% of them or so. So we can also see that here in October, we had that kind of release from below normal conditions as the rains came in and kind of setting us back into normal. Similar plot on the right here, just showing an average stream flow index. So this just showing that red line, indicating that we were below normal conditions, and we've kind of encroached up to those more normal conditions. And then backing up even further with the 7-day average stream flow, we can see this immediate response and this thick black line indicating the current year. These colors in the background indicating the percentiles, with the same color code we see in all of these plots. So we had been skating at below normal to much below normal ever since the summer. And so with these rains kind of coming in October, it brought us right up to almost above normal there for a bit, and kind of back in normal flow conditions. And then we don't actually have a current 2025 water year cumulative runoff generated yet for some reason, but just showing here as we closed out the water year, having the 2024 water year with normal flow conditions, or cumulative runoff, sorry, as well as comparing that to the last water year in 23. We're a little better than we were the end of last water year with regard to cumulative runoff. So now looking into kind of a little longer time frame, the last 14 days. So this is November thus far. Looking at November's monthly average so far, we see a similar trend as the 7-day average. Normal conditions in western part of the state, and much of the eastern part of the state will also being normal, with some exceptions of below normal and much below normal. as well. And then we have this, above normal kind of anomalous area over there. At least it stands out from everything else. Comparing that to October of last year, that same basin, that's over, got a much below normal conditions over there in October. The Upper Columbia still at record lows in October, but we see that, of course, we're ending up a little better now than we were in October. We did have some indicators here of much above normal from some of the rain that Karen had mentioned, kind of hitting the northwestern part of the state and Bellingham. Comparing this to October of 2023, pretty similar if you just kind of judge by the relative distribution of colors across the state. But of course, this year, or this October, showing the northwestern part of the state certainly having much more normal flow conditions compared to last year, where we had some below normal conditions in that region of the state. So November here, we just looked at this one, I think. So maybe we'll just skip past it, have a duplicate slide. Or maybe I'm going backwards. Here we go. All right. So now we're looking again at this October, comparing that to some of our drought years in recent history, showing that we have still a pretty dry October with regard to stream flow at USGS gauges, compared certainly to 2019 and 2005. But additionally compared to 2001, 2015. So even though we have had kind of an increase in our stream flow that kind of saved us from much below normal conditions, this October still seems a bit drier than the October in some of the preceding drought years. Looking back again at 7-day averages now, but then backing up to compare that to other years as we kind of think about that longer term trend. Excuse me. We see this, that typical increase that brings us into more normal conditions in many years. We kind of had a relatively early rise in that compared to the last 2 years. If you see, we kind of dipped much below normal, and didn't kind of come up until a little bit later compared to this year with our October rains. And then comparing that also to the drought years, you can see we had this, as I mentioned prior, the first time we looked at just this year, kind of that duration hydrograph riding at the below normal to much below normal, which kind of mimics 2019, but not to such an extent, not as bad as 2015. So maybe we're a little bit closer 2005 and 2001, with the exception of, 2001 was very, very low throughout the whole year. We had some better flow conditions earlier in the year, this past 2024. Now moving to groundwater conditions, I guess I can delete this at some point, but still just reminding folks, if they haven't joined in the last couple of meetings, that the Scatter Creek well has been discontinued. So we're no longer reporting on that as a long-term reference gauge. Actually, all 3 gauges in the western part of the state were discontinued due to lack of federal funding. We've just got 3 in the eastern part of the state, and we're looking at Davenport and Whetstone wells. Davenport well, looking at the last year's conditions here in that thin line on the bottom compared to this year's conditions, the thick blue line, this kind of dotted gray line being the median. So current conditions at Davenport being below median, but above where we were last year. Looking at that in the more long term, we had been kind of watching this since we had this kind of recharge, long-term recharge event and kind of a depletion again, kind of keeping an eye to see if we start to slowly climb back up to a larger recharge event. That's yet to be seen, but it looks like we kind of still coming down a little bit and haven't quite started to recharge conditions there. Now the Whetstone well near Walla Walla in Waitsburg, same type of plot. So the blue line showing this year, now showing that we are below both last year and median conditions at this well. And if we back out to more long-term trends, showing also that we're dipping down, kind of getting close to about the lowest we've had since about 2019 at that well. With that, just a brief summary, 7-day average stream flow at our 8 index gauging stations showing primarily normal conditions within the western part of the state, below normal in the eastern portion of the state. Our cumulative runoff hydrograph showing us about normal for the water year 2024. And monthly average groundwater conditions, or just current conditions now, kind of having a lot of changes with our kind of statistical plots that and available data to show kind of the longer term trends for groundwater wells at the moment. But just comparing them, we're below the median and above last year at Davenport well, and at Whetstone being below the median and 2023. And with that, concludes what I've got. Thanks.
Awesome. Thank you, Nick. All right, with that, we'll go to Matt with NRCS.
Good morning, everyone. Let me share my screen real quick. All right. Hopefully everyone can see my screen.
Not yet.
Oh, for some reason that just stopped sharing.
Oh.
There we go.
Great, thank you.
All right. So, brief overview. Be able to give an update this time on snowpack conditions, which is exciting. Then precipitation and soil moisture. Some of these slides I'm going to brush through a bit quickly since I have 10 minutes here and I got a little too excited adding information into this presentation. There we go. All right, just some key general reminders for early season snowpack, especially when looking at a map or our interactive map. Early season snowpack is not necessarily a good indicator of how the winter will progress. On the right is a basin snowpack profile plot of some years where we did have similar early season snowpack, some years exceeding normal, some years with snowpack right at normal, and other years where snowpack was below normal or melted off extremely early. So just keep that in mind when we're thinking about early season snowpack. I know a lot of people, especially the public, get excited, but it's not really a great indicator for how the season will progress. Early season snowpack can yield extreme percent of normal values, since median values at this time tend to be quite low. So any deviation from a low median value is going to yield a pretty extreme percent, either positive or negative. And in some areas we've seen more precipitation falling as snow early in the season. And so this lack of precipitation falling as rain can potentially have an impact on soil moisture and stream-based flow recovery going into winter. So that's one thing to keep in mind, and that, of course, can have adverse implications for water supply come spring. All right. And moving into snowpack conditions. First showing the statewide plot. Off to a fairly good start. The winter, or I guess the snowfall, really began almost exactly on November 1st. Statewide snowpack is 226% of normal, and we'll see here in a second that that's not evenly distributed across the state. And then the percentile ranking is 72 there. Taking a look at basin snowpack, I went down to the sort of sub-basin level instead of looking at those larger major basins, just so we can get an idea of where our lower snowpack is right now. And I wouldn't say any of this is a concern. We're still, like I said, early in the season, and where we see red on the map are typically sites that have a fairly low median value anyways. So I wouldn't note those as really a concern at this point. But just showing the spatial distribution across our snow-tailed network of snowpack. Generally, the early season is off to a good start in most areas, especially I would say the North Cascades and areas around Rainier on the Olympic Peninsula and out into the Upper Columbia Basin as well. And taking a look at the percent of average. So that just kind of factors in more of those years where we do have more extreme events, and just comparing current values to that average, which of course our office, I should capitalize that normal, but our office doesn't use the average as normal. We use median value, but just showing areas where there is sort of low snowpack, at least for this time of year, and areas where we're seeing higher snowpack at our snow-tail stations. And now getting into precipitation conditions, looking at the water year-to-date precipitation basin map. Some interesting things, I think, to really hone in on. One is the northern and southern part of the Cascades are seeing fairly close to normal water year-to-date precipitation, slightly above. And snow-tail stations, mostly in the Central Cascades, are seeing below normal precipitation for this time of year. In addition to that sliver of the Northern Blues that's in Washington. Across the Upper Columbia, water year-to-date precipitation is near normal as well. And statewide, water year-to-date precipitation is at 101% of normal, so almost right at normal for this time of year. And now taking a look at some of the percentiles, just to show sometimes yellow can be confused with closer to normal. And if we look at the percentiles based on that normal period, especially for stations in the Central Cascades, we can see sort of a developing precipitation deficit at several of those stations. So I would say that would be a note of concern for conditions so far this season. And as the previous map showed, we're seeing generally pretty good or very good so far precipitation conditions in the much of the northern Cascades and down around the Helens area in the southern Cascades and across the Upper Columbia Basin. Month-to-date precipitation so far in November, most of our sites have seen slightly above normal precipitation. October was a fairly dry month for many parts of the state, more so east of the Cascade Crest towards the Idaho border, where most of our sites saw moderately to well below normal precipitation. And just to show sort of a time span from the beginning of last water year up to this point to maybe give us some insight into areas that are experiencing continued precipitation deficits, and that's several sites on the Olympic Peninsula, out into the Central Cascades and up into the North Cascades. So really like to see above normal precipitation conditions at those stations to alleviate some of those more medium-term deficits as mainly a result of last year. And briefly touching on soil moisture. So I really wanted to focus on a lot of stations in the North Cascades since we saw pretty poor soil moisture conditions there throughout the summer. And we can see some recovery with these recent storm events, but still pretty poor, I would say, soil moisture conditions at our Rainy Pass and Harts Pass snowtail stations, and some better recovery at Park Creek Ridge and Brown Top, so a couple of our higher elevation sites in the North Cascades. Now taking a look at some scattering of sites across Washington on the Olympic Peninsula, and I forgot to update Burnt Mountain. It's showing Salmon Meadows, but just touching on sites that are near normal. So Bucking Horse on the Olympic Peninsula, Ragged Mountain just northeast of Spokane, and I neglected to update two plots. It looks like I apologize, but Moses Mountain was approaching normal for soil moisture when I was looking at that. And then Sourdough Gulch in the Northern Blues is still trending and almost reaching a period of record low. So not really seeing any recovery at that station in particular. And we can see from some of these spatial products that there's general agreement with, I think, drier conditions in general in portions of the Lower Snake and the Umatilla Basin, so right along that Washington-Oregon border. And then some consistently dry, I think, conditions between those two products along the eastern slopes and portions of Washington, that central area, so upper Yakima, and then up to parts of the eastern slopes of the North Cascades as well. And briefly looking ahead, I just wanted to show the atmospheric river forecast since it will impact the region over the next several days, expecting or forecasted a couple of weak AR events, and currently in a more moderate event that has produced some snow across the region. And this is just a quick look at the freezing levels. So quickly just looking at the upper Yakima showing freezing levels throughout this recent event down to about 2,000 feet, and then rising, and the North Cascades generally showing a fairly low freezing levels, which is better for that mid-elevation snowpack there. And that's all I have. I'll just leave this up since I just brushed over it really quickly.
Awesome. Thank you very much for that, Matt. And again, we'll be posting slides on the website. I'll put that link in the chat when we're done here. But I'm going to transition to Amy with the Northwest River Forecast Center for her time today.
Thank you, Caroline. I am working on sharing. Do I have permission to share right now?
You should.
Okay.
Great.
And are you seeing that?
Yes, thank you.
Okay, good. All right. So this is me, a hydrologist with the Northwest River Forecast Center. I believe online we have Brent and George as well. So you can locate your local service hydrologist from the Northwest or National Weather Service here. Jumping into precipitation and runoff for the water year so far. I'm just showing the precipitation here on the left, although others have already covered it. I did want to point out the October atmospheric river that came through in late October kind of clipped the corners here of contributing areas to Washington. So you'll see these deep greens and blues even in the areas that were hit there. And hit again in this most recent event. But the runoff map on the right-hand side still shows a lot of oranges and reds for the water year so far. So still sort of running deficits, I think, left over from the lack of snowpack last year and the super low runoff that we saw there. But Other areas, namely the main stem of the Columbia, you can see coming through here in green, have returned to normal, and some of these areas that got hit with that October storm. Looking ahead to the 10-day precipitation forecasts, as Matt alluded to, we're still in an active weather pattern and expect to stay in one. So the far left-hand map is showing the inches of precipitation projected to fall in the next 10 days. I pulled these maps yesterday, so they are a day old. And then this middle map shows the same information as deviation from climatology. So these greens show areas where more than normal is expected to fall in the next 10 days, as does the far right-hand map, which shows percent of normal. So you can see this big blue blob here in northeastern Washington. It's expected to get much more than normal there, even though it's not as much as what Western Washington is going to get. I will say that in general, the River Forecast Center here was staffed up and ready to maybe deal with some flood forecasting. And so far that has not come to fruition. So I think a lot of the precipitation forecasts have been somewhat overdone in the past week or so. And I did want to point out this forecast trend tool that we have. So if you go to our 10-day meteorological forecasts and click on this forecast trend, it'll pop out the forecast trend for each of the 10 days. And actually you can adjust the calendar to look at many days in the month. And you can see each day how the forecast for that day evolved through time. So in this case, I believe this day right here was expected to be really heavy, and we'll see how it was observed. Those numbers are still rolling in now, but I believe it came in lower than normal. So again, just looking at the water year runoff on the left-hand map and comparing it to the April through September, I will call that a pre-season forecast. It's very early in the year to be looking at water supply forecasts for the April through September period. I think Matt just did a really great job of explaining why you don't want to look at snowpack necessarily this early in the season. Same goes for these forecasts. They're going to trend towards normal because of how much unknown we still have yet in the snowpack building season. So I wanted to really put these maps side by side and just keep in mind we're running on a deficit here for a lot of Western Washington in terms of runoff. So those April through September forecasts look really optimistic to me right now. And also because we've had a El Nino conversation today, I wanted to point out that we have these graphics which correlate the historic runoff in volume for the April through September period on the y-axis to the Oceanic Nino Index. You can change this index to a couple other indices that we have available. But in this example, I'm showing the ONI. So you can see how well the Oceanic Nino Index correlates to historic runoff. The correlations on these plots are pretty poor. I always call them shotgun blast scatter plots. But these blue lines do describe the trend in the data. There's the correlation coefficient down here. And you can see if we're going to trend in the weak La Nina to neutral zone, you could expect this water year to fall along this spread about right here. And when we do complete the October through December period, you'll start to see a box and whisker plot appear here with our current water supply forecast. I'm just showing some of these as examples from around the state, and you can see how the slope of the line varies and how the correlation varies. And you might want to zoom into your individual forecast that you follow to look at them. So here are some examples from the west side and some examples from the east side. I was trying to pick out a pattern, maybe in more rain-driven basins, there's a stronger correlation or a weaker correlation, and I really couldn't pick out any. So I encourage folks to look at the forecast that they follow. That's all I was going to show today. I don't want to dive into our forecast too much because it is so early in the season. But overall, runoff since October 1st has been largely below normal. I think we're still being affected by the dry months that we're coming off of. But we have entered into an active weather pattern since the end of October, and that is expected to continue. again, snowpack building is expected in those 10 days, as Matt alluded to. And the precipitation forecasts have been somewhat greater than the observations that we've seen come in the last 10 days. Any questions? I'm going to jump off the meeting after this, so get your questions in now.
Yes, thank you, Amy. Any quick questions for Amy?
I've got a quick one, Amy. Sorry if I missed it, but do you think all of these rains we've had so far have effectively kind of wetted up the soils enough to prime the system so that your models will be working a little kind of more effectively?
Yeah, I do hope so. I kind of thought that October rain would have gotten our soil moisture states aligned a little bit better. But now in this November event, we were really forecasting rises in rivers that didn't materialize, or at least didn't materialize as big as we thought they were going to. So hopefully after this one, we have things primed a little bit better. It's hard to know if that was overdone QPF or if that was, hydrologic uncertainty in our model. But yes, that is a very good point. All of the soils that are, or the rain that's coming in now and wetting the soils should help us with our forecasts later. This is much better than a couple years back when we had precipitation fall as snow onto dry soil, and then we really had no idea how wet the soils were going into the season.
Right. Cool. Thanks.
Great. Thank you very much, Amy.
Sure.
And then you have to run, but folks have other questions for Matt or Karen or Nick with USGS. We're going to stop the recording now. If you have other questions, we're happy to take some time for that.